Commissioning an Ethernet interface, setup and prep for network operation. Physical install, step number 1. Before you can commission anything, you have to do the physical install. Nowadays we have things like this, where you just plug it in the USB port on your computer. It automatically detects it and whatnot. Last night I was playing with my upstairs computer because having network issues with it, trying to determine whether it is the network interface card, the NIC, or some other problem.
Fine.
I haven't yet. Next step is to get something like this, pull the NIC out of it, and switch over to USB based. Fortunately, it's new enough that it has USB 3.0, so I can get a full gigabit connection out of it. Anyway, it can be as simple as this, or in my case, at home, there is a physical NIC that I had to plug into one of the PCI Express expansion ports on the motherboard, which means opening up the case and all that good stuff. Neat thing about these is it's USB, so it's plug and play. You just plug it in. On mine, it's PCIe. It's not wireless, it's wired.
Oh, word.
In my case, PCIe is not hot swappable. So I have to power down the computer, disconnect the power supply from it, break out the anti-static strap, ground myself to the machine, and all that crap. So this is way easier.
If you didn't use the ground strap,
you can generate an ESD, an electrostatic discharge, damage many things in the computer. Not to mention, whenever you touch something that is grounded and you have static charge built up in you, it hurts. And you ever walk across the carpet in the wintertime, touch the doorknob? Yeah. There are ways to mitigate that, by the way. Easiest one is a key. Anything metallic. Make sure you got a good tight hold on it and use it to touch the doorknob. Spark is out here instead of here. It's not the shock that hurts, it's the heat from the spark. So if you move where the spark happens, it doesn't hurt.
you ever tried that?
Oh yeah, many times. Okay, so hardware installation, you have to physically install the network interface card or module into the device, such as computer, switch, router. I haven't seen very many switches that are have pluggable modules, other than going to do an NSFP module, which is fiber connection. Cabling, Ethernet cables must be connected from the interface to the appropriate network device, such as switch, router, or other network device. The type of cable nowadays really doesn't matter as much, because most devices are capable of determining whether it has a straight through or a crossover cable connected to it, and it adjusts itself accordingly. They've been able to do that for the last, oh gosh, probably 20 years. Long time. Used to be if you needed to connect computer to computer, you had to have crossover cable, because otherwise transmit goes to transmit instead of transmit going to receive. I'd say most devices nowadays are smart enough to be able to figure that out. IP address assignment, vast majority of the time you're going to do DHCP as by far the easiest. However, you can assign static addresses. The only bad thing about static address is if you assign the same address to more than one thing, it doesn't work very well.
What is a good example that they would use DNS? Like, and years ago, I worked for this IT firm, and like the vast majority, I'd say a good 80% of the clients they had DHCP, but there was a solid 20% that actually used DNS. What would be some reasons?
Well, DNS and DHCP are not even closely related. You're comparing apples to oranges.
I'm getting backwards here. Do you understand what I'm trying to say? And what would be a good example?
DHCP versus static.
Yeah. So what would be like a good
Well,
example?
DHCP is typically reserved for general use.
Right. So what would
If you're talking static on an ISP, that is probably for a business customer or a residential customer that is paying for a static IP. The reason why you would want to do that is if you're going to host a web service or have your own email server, you know, that kind of thing.
What about inside of the business? What would be some perks to static IPs, or if there's any at all?
Well, if you're going to be a business and you want your website to be accessible all the time, if your IP address dynamically changes, and it's dynamic host control, then some days your website is available and some they're not. It just depends on whether you have your name server automatically update whenever your IP address changes or not. The authoritative server. I completely lost you now?
No. Never understood why they did that.
Subnet mask. You have to specify a subnet mask to define the range of IP addresses that communicate directly with the interface. You're not on the same subnet, you can't talk to each other. Traffic has to be routed. Remember that from when we were doing subnetting and supernetting, which thoroughly confused everybody. Gateway configuration. You set the default gateway for communication outside the subnet. If your computer, phone, tablet, you know, whatever the device is, can't find an IP address locally, then it goes out the gateway. That's next hop, what they call it. So if I can't find it locally, it can't, you know, it has to be somewhere else. I'm going to send it out the gateway and let the router worry about it. And then DNS, you have to configure your DNS server address for name resolution. Most of the time, that's your local router, which is assigned by your ISP. But you can specifically say, no, I want to use Cloudflare or Google or Layer 3. You know, there are dozens and dozens of DNS providers out there. Some of them do their own ad filtering and things like that. Others don't. I run a Pi hole at my house. So all my computers think that their DNS server is, well, it is. They don't think that it is the Pi hole, and then the Pi hole communicates through unbound to the root servers to find out what IP addresses that it needs are, if it doesn't know it locally.
What is unbound?
It's just a recursive DNS lookup. Protocol and VLAN configuration, if applicable. Ethernet protocol, and you'd set the Ethernet protocol settings such as speed, which 10, 100, 1000 megabits. That's actually mebi bits, by the way. MEBI. Mega is 1024. Mebi is 1000. And the duplex mode. Again, those are all pretty much automatic settings nowadays. When you plug in your computer to the router, switch, whatever, one of the first things it does is say, hey, we need to negotiate how fast we can talk to each other. Does it really quickly. And then half full duplex, and then one way simplex. If you're wanting to communicate with a network, it's going to be full duplex because you have to be able to talk and listen. VLAN setup, configure VLAN settings if the network segments traffic with VLAN. The only way you know that is if the person that runs the network told you, or you are the person that runs the network and you set it up that way. Testing and verification, link status. You ever heard anybody say, I got a link light? Yeah. There are two lights on each one of these, one on either side of it. Sometimes they're above it. One of them is a link light, which is the link status. That tells you that the cable is connected from end to end. Means nothing else. Okay. Ping test. You perform a ping test to ensure communication with other network devices.
It's just
Go on.
ping and IP address.
Or FQDN. That works too. FQDN, fully qualified domain name. The URL, www. whatever. Traffic test. To test data traffic to confirm functionality under typical conditions. Hopefully when you commission your interface, it is a typical setup. And easiest thing to do is jump on a web browser, speedtest.org, run speed test, make sure you got good up and down and whatnot. Speed test does latency, which is ping, how long it takes for information to get to and from whatever server they're going to use for the speed test, which is negotiated automatically. That's latency, jitter. I know I think of it eventually. Jitter is when they're doing the ping test. They want to see what the difference is, the range of times it takes for the ping to go back and forth. So they do it several times. Gives you an idea of how stable the connection is. And then of course the speed, both upload and download. Typically, upload is going to be a lot slower than download, unless you purchase a synchronous connection, which just means that upload and download speeds are the same. I use Brightspeed at home, so I've got a gig up and down. as opposed to when I was with the cable company, Mediacom. Yeah, I had 2 gigs down and like 200 megabits up. So yeah, it was just way unsynchronous. Of course, how often do you upload things? Security configuration, if applicable. This day and age, it's applicable. Firewall rules, you want to set rules, control traffic through the Ethernet interface. Access control, apply MAC address filtering, or port security to restrict access. So one of the things that I use on my network is MAC filtering. So you request to join my network, you end up in a walled garden so you can't get to anything. And I go in and say, okay, allow that MAC address. And then depending upon which network you're connected to, if you're on my guest network, you can't get to anything but the internet. But that's all done through MAC filtering. Documentation monitoring. Want to record the configuration settings, IP addresses, VLAN assignments, and security settings. Yeah, you definitely want to make sure that document things, because somewhere along the line you're going to fat finger a keyboard and things aren't going to work, and you're going to drive yourself nuts trying to figure out what happened. If you got the documentation that says, hey, this device is this address, this device is this address, and so on, these are the settings on it, makes it a lot easier to troubleshoot later. If you're doing it at home, it's probably not as big of a deal, but get into a larger environment like school or work environment, becomes a lot more important. And then monitoring your setup. Configure tools to monitor Ethernet interface performance and traffic. That's usually done at the router level. Do a PTOP or many different other ways to monitor what's connected to the network health, and that kind of stuff. Integration and commissioning. Integration testing, you want to test with the network to make sure that you have seamless operation. Make sure you can stream, upload, download, and whatnot. And then commissioning, once tested, formally commission the Ethernet interface into production. That would be more typical of an industrial or commercial environment rather than at home. But you're not really, production. Well, I guess it is production production model. If you hook up your wife's computer and it doesn't work, you're definitely getting a help desk ticket for that. Which sometimes includes lots of screaming and yelling. Nobody wants to be screamed at or yelled at, unless you're like into that kind of thing.
Yeah.
Considerations. Vendor guidelines. Follow manufacturer-specific guidelines for configuration. 99 and 9/10% of the time, they tell you plug it in, turn it on. It's all self-adjusting. Security best practices, protect the interface and network from unauthorized access. Firewall. Make sure you lock down your firewall so that nothing can get in. Most of them by default are locked down. Network documentation, maintain accurate records to aid troubleshooting and future expansion. And in summary, by following these steps, you can commission an Ethernet interface effectively, ensuring it is properly configured tested and integrated for reliable network operation. End.